Part of the beauty of this system is that we're really able to reduce computation down to its base components, said Rice undergraduate Colter Decker, lead author of the study in the Proceedings of the National Academy of Sciences. He said electronic control systems have been honed and refined for decades, and recreating computer circuitry, with analogues to pressure and flow rate instead of voltage and current, made it easier to incorporate pneumatic computation. Decker, a senior majoring in mechanical engineering, constructed his soft robotic control system primarily from everyday materials like plastic drinking straws and rubber bands. Despite its simplicity, experiments showed the system's air-driven logic gates could be configured to perform operations called Boolean functions that are the meat and potatoes of modern computing. The goal was never to entirely replace electronic computers, Decker said. He said there are many cases where soft robots or wearables need only be programmed for a few simple movements, and it's possible the technology demonstrated in the paper would be much cheaper and safer for use and much more durable than traditional electronic controls. As a freshman, Decker began working in the lab of Daniel Preston, an assistant professor of mechanical engineering at Rice. The project turned into a months-long collaboration between the two research groups, and Decker had 9 co-authors on the study, including co-corresponding authors Preston and Whitesides. Decker and colleagues created 2 components: a piston-like actuator that translates air pressure into mechanical force and a valve that can be switched between 2 states, off and on. The components were made from parts that included plastic drinking straws, flexible plastic tubing, rubber bands, parchment paper and thermoplastic polyurethane sheets that could be bonded together with a desktop heat press or a hot iron. The research team showed the 2 components could be combined in a single device, a bistable valve that operates like a switch and uses air pressure as both input and output. A specific amount of air pressure is needed to flip the switch between off and on states. The valves are held closed by rubber bands, and they are programmed by adding or subtracting rubber bands, which changes the amount of pressure required for activation. In tests, Decker showed the circuits could be used to control a soft, hand-shaped robot, a pneumatic cushion and a shoebox-sized robot that could walk a pre-programmed number of steps, retrieve an object and return to its starting location. Having both means the pneumatic control circuits can be programmed digitally, with the ones and zeros that you think of in a traditional computer. But we can also bring in analog capabilities, things that are continuous, he said. That allows us to really simplify the overall system architecture and achieve new capabilities that weren't accessible in prior work. It is rare for an undergraduate to be the lead author of a study in a journal as prestigious as the Proceedings of the National Academy of Sciences, but Preston saw. The undergraduates at Rice are truly top-notch, and Colter, in his case, actually has risen to essentially what I would say is the level of a Ph.D. student in terms of some of his output as an undergraduate researcher, Preston said. Additional co-authors include Hui Joy Zhang, Samuel Root, Jonathan Alvarez, Giovanna Trace and Lucas Will of Harvard, Anup Rajapan of Rice and Marcus Nemitz of Worcester Polytechnic Institute. The research was supported by the Department of Energy, DE SC 000989, the National Science Foundation, 2,144,809, 2,011,754, 2,025,158, the Rice University Academy of Fellows and the Harvard University Center for Nanoscale Systems. Video. U2.be/0D22S2CMLXC materials provided by Rice University. Original written by Jade Boyd. Note: content may be edited for style and length. Programmable soft valves for digital and analog control. Proceedings of the National Academy of Sciences, 2022. 119, 40, doi. 10. 1073, PNAS. 2,205,922,119 Rice University. 2022, September 29. Fluidic circuits add analog options for controlling soft robots. Science Daily. Retrieved September 29, 2022 from ift.tt/gka8fm Rice University. Thanks for watching. Please subscribe my channel for more videos.